Okay, so our last notes on related rates have to do with cones. Cone problems, there's going to be like a little extra step in the beginning, but the problem will work out very similar to the ones that we already had. So in your notes, go to where you see this cone right here. Okay, so in this problem, it says water is dripping out of an inverted cone at a rate of 2 cubic feet per minute. Okay, so think of it like those little paper snow cone cups. You know, water's leaking out the bottom of that cone, like in this picture. The cone has an altitude of 10 feet and a base with a diameter of 6 feet. When the height of the water in the cone is 3 feet, determine how fast the height of the water is changing. Okay, so what are they asking us to find in our Fuigi? The rate of the height of the water. So we're trying to find dH over dt. Now, do you think this is going to be negative or positive? Is the height of the water increasing or decreasing? Decreasing. So the rate should be negative. And we know that because water is dripping out. Okay, what about the when?
H equals 3 feet.
H equals 3 feet. What about the given? What given rate? 2. So what does that represent? I see, without even reading the problem, I see cubic feet per minute.
C of V over dt equals 2.
Yeah. It has to be talking about volume, right? When you see cubic. And again, because water is dripping out, this volume is decreasing. So even though they don't say it's decreasing, that's implied in the problem. So you've either got to pick up on the negative here and make sure that that happens, or pick up on it here. So you kind of have two chances to do that. This negative, if we do this part correctly, will cause our answer to be negative. So that's just a check. Now I see here that this equation is V equals 1/3 BH. All right, I'm going to write it as 1/3 pi r squared h. I'm going to put a pi r squared in place of b, because big B represents area of the base. Base of a cone is a circle. There we go. Okay, now was there any other information they gave us that I have not written down?
The A and B.
Okay, so they say the cone has an altitude of 10 feet and the base a diameter of 6 feet. See how this says the cone? It's not talking about the water. It's talking about the actual container. So let's draw this on our picture and see what this has to do with anything. So that's 6 feet. Now my equation over here has r and not diameter. So what would the radius of this cone be? 3 feet. Okay, so we have r and we have h. Okay, this is just a proportion of the cone. It's not telling me that the height of the water is 10. We already know that on our when, the height of the water is 3. Okay, so the whole reason, let me just scooch back over here, the whole reason that that part is going to be important, notice I didn't even put it with my Fuigi, is because if I look at this equation or this formula, V, okay, V's good. I know something about V. 1/3 and a pi, that's fine. R squared, or R, I don't know anything about R. Okay, so this little r right here, I really want to kick it out, but I'm going to have to replace it with something. H is okay. I know what H equals, and dH over dt is what I'm looking for. So somehow this over here is supposed to be telling me something about R. All right, now no matter how much water leaks out, it's still going to be a shape of a cone, and it's going to be a similar cone. Do you guys see that? The small cone's similar or proportional to the bigger cone. So this is what we're going to do when we have this. We're going to set up a proportion, and you have options here. I'm going to set up the proportion as 3 over r. Okay? So the radius of the cone, of the container, over r, what would that equal to for the other piece? 10 over h. You could have set up the ratio a different way. You could have said r over h. So listen to what I'm saying. R over h, what would that equal? 3 over 10. In the end, it does not matter how you set up this ratio. Okay, this proportion, because as soon as you cross multiply, everybody would get 3H equals 10R or 10R equals 3H.
Is R supposed to be the radius of the water or of the cone?
So right up here, I'm talking about the cone.
So is 3 not equivalent to R?
Okay, so the 3 and the 10 have to do with the cone. The R and the H have to do with the cone and the water and any of the similar cones. I wasn't as clear as I should have been there. Because what I want to do, like my ultimate goal of why I'm even doing this, is I want to be able to replace this R with something over here in terms of H. So, like, I know that if this cone was full of water, they would be the same, right? The water in the container would have the same numbers. But even as water drips out, this little R and this H, if I kind of draw this slightly different than I had, if I do something like that, it's still going to be proportional with the 3 and the 10. Does that make sense? Mm-hmm. Okay, so when you're looking over here and when you're doing a cone problem and you got this proportion, you're either going to get H by itself or R by itself. If I want R to be gone, because I don't know anything about R, that's what you want to get by itself. We want to replace R with something R equals. So if 3H equals 10R, what does just R equal? Yeah, I'm going to write it as 3/10 H. It's going to make the next part a little bit easier. Okay, so I know this seems like kind of different than what we've been doing, and that part is true. Okay, the rest of this isn't going to really be that much different. So let me just remind you, here's my volume of a cone. I don't know anything about R, so I got to replace R with this thing. So let's go ahead and do that in our formula. And I'm going to do all this before I derive, because why derive something that's really difficult if you can simplify it down first? Deriving sometimes is the hardest part, so let's make that easier on ourselves and go ahead and right now, in place of R, let's plug in this 3/10 H. And so this formula in red, that was the given formula. The formula I have here in blue, it's the same formula for this problem. It's just, see how there are no more R's? That's good. That's what I want. I don't want any R's. I only want H's. Now, I could go ahead and derive both sides right now. But can I simplify this just a little bit more so that the deriving part is even easier? Yeah, let's go ahead and square this. So this would be 9 over 100 H squared. And again, I could derive right now, but it'd be easier if I simplified even more. The more you can simplify this formula and get it down to something pretty small, the easier the deriving part will be. Because so far, I would have to use product rule. But if I go one more step, I can get out of product rule. So 1/3 times 9/100ths. That's going to be 3 over 100. Okay, the 9 over the 3 makes a 3. And then see how that H turns to H cubed? I now have a formula that will not require product rule. It's simplified as far as we can go. So this is the extra step in a cone problem. It's in the preparation. Okay, instead of using this formula in red, you're either going to replace R, like we did in this problem, or it could be that we wanted to replace H if they had given us information about R instead. We'll see that in the next example. So when you're doing these cone problems, you're always going to get, oh, my thing just died. Hold on. Okay, so let's go ahead and rewrite our formula up here. It's nice and neat and concise, and I don't have to use product rule, the best part of it. Okay, so let's derive both sides with respect to t. From here on out, this is going to be like any other problem. dv over dt. What about the right side? This 3, we don't have to do product rule. It's only of one variable. But this 3 needs to get multiplied to 3 over 100. What would that equal? 9 over 100. And you got your calculator there if this is, I mean, you should be able to do that without a calculator. But in case you needed it, it would be there. And then decrease your power by 1. And what should I multiply by? dH over dt. Because I took the derivative of an h. Okay, now we're ready to plug in. After you derive, you plug in. So dv over dt, let's put in a negative 2. 9 over 100, we'll rewrite that. H, that's 3. And dH over dt is what we're looking for. And so again, you can use the solve feature, you can use algebra, use your calculator. I'm not going to spend a lot of time on that right now. Your answer should be, if you get an exact answer, you get negative 200 over 81 pi. And what would my units be? So for height, just feet, time would be minutes. If you got a decimal, it would look like this. I think it goes out further than this, but it would be something like this. So we need to be accurate to 3 decimal places.
But do you want us to do that, or do you mind if we just...
You can leave it more accurate than that, but don't go any less accurate. This is perfect. And really, on a these tend to, on the AP test, be multiple choice. So you got to just go with what they have there. Okay, so that's how you do a cone problem. You have to, in the very beginning, either replace R or replace H. That's really the hardest part. And right now it's difficult because it's new. Once we practice it, it won't be as bad. So let's look at problem 2. Okay, so on problem 2, a truck is pouring gravel onto the ground in a cone-shaped pile. So this time, instead of leaking out, it's forming a cone. So we're not talking about an inverted cone, we're talking about a right side up cone. And it says the height of the cone is always twice the radius. Interesting. The radius is increasing at a rate of 3 inches per second. Find the rate of change of the volume of a cone when the radius is 5 inches. Okay, so what should go next to the F? Find. I see rate of change. So I'm going to go d over dt. D of what? Of volume. So dv. And you think this is going to be positive or negative? Is the volume increasing or decreasing? That's what you should be asking yourself. Positive, right? And so that's a good thing for us to know. We want to kind of make sure our answer is positive. If we do everything else right, that should work out. Okay, when the radius is 5 inches. And then it says the radius is increasing at a rate. Okay, again, I see rate. That's d. Radius, so dr over dt. Increasing would be positive, so positive 3 inches per second. And then my equation, again, is going to be 1/3 pi r squared h. That's what we start off with. So setting up Fuigi, same as what we've done before. Was there any part of the problem I haven't written down, though? It says the height is always twice the radius. So we get to help bypass that whole proportion thing. They straight up gave us what we needed. Okay, look at our formula here. We have v. Okay, good. That's what I want. I want dv over dt. 1/3 pi, that's fine. R, I know r and dr. Okay, so r is fine. What we don't like is this h right here. I don't want h to be there. I don't know anything about h. Plus, if I leave this here, then I have to do product rule, and I have to go off and do a side problem to find h or dh over dt. So it's just easiest in the very beginning to replace h with what it equals. Before we had to do a proportion. Here, I can just rewrite it. And in place of h, I'm just going to put in a 2r because it said the height is twice the radius. And if you wanted to, just for fun, do the product rule, you could derive now. Okay, you could. Let's though not. It's Friday. So we need to do the 2 times the 1/3. And I just call this cleaning it up a little bit. We just want to make the formula a little bit cleaner so that deriving is easier. And that's what you do in a cone problem. With some information in the problem, you're either replacing R or you're replacing H. And you just kind of have to look through the problem to figure out which one. Okay, what's the next step? Deriving, yes.
When you distributed the 2 to the 1/3,
Mm-hmm.
then you'd get 2/3 pi, and then R times 2R. So then
This is all being multiplied. It's 1/3 times pi times R squared times 2 times R. So I'm not distributing. That's not really what you said, but maybe. So like this 2, I'm going to multiply it to my other constants, 1/3 and pi.
so you're not using the square 2 to multiply. You're using the 2 coefficient.
Right, this has nothing to do with the derivative. This 2R came from right there. Yeah. Okay, now I am deriving. So now is when we do need to put that 3 times 2/3. So 3 times 2/3 is just 2. If you need to, use your calculator there. I'd rather that than you get it wrong. Decrease the power by 1 times dr over dt. Now we're ready to plug in. I'm looking for dv over dt, so I rewrite that, and I just plug everything else in. And this one's even a little bit easier because it's just, what does all that equal? And it equals 150 pi cubic inches, because we're talking about volume here, per second. If you wanted to get the decimal, I believe it is 471.239. Okay, I know I went through that pretty quick. Are there any questions? So what do you have to do at the very beginning of a cone problem? You have to either replace the R or replace the H. Here's